So we're down in Escalante kind of fretting about what's going on and stuff, and I realized, Utah maintains these maps with, here's like I-15, here's a map we had to take, and all these cameras. You can click on the cameras and see what's going on. So like Monday morning, I was sitting there clicking and watching, enormous amount of snow dumping down and like lanes that were barely open and cars going 20 miles an hour, and I said, I don't want to risk my life and my family's life on those roads, so we're going to just wait it out here and come back later. And anyway, it just kind of made it appreciate, right? Sometimes here we're interested in being in a tech field, and hopefully you sometimes remember that it's not all about, games and banking software. Sometimes there are applications that, actually can save a life or help you and your family get home safely, and keep that in mind sometimes when you're working on some of this stuff, that there are all these good applications of technology as well. And anyway, that's, I hope you all feel some of that sometimes working on this stuff. That's part of the reason maybe you want to be in this field. Now, of course, it did cross my mind that here's all these cameras, and we're about one generation of camera away from having them all be like Ultra 4K cameras that can read your license plate as you go by, and now people can track exactly where you're going everywhere you drive around the state. And there's that flip side of technology as well, with privacy and government intrusion and things like that. And so just be aware there's always a give and take on both those things. Anyways, could have been more exciting. I was glad to not get too exciting by waiting instead of driving through the storm. Anyone else have any exciting storm stories? You want to share? No. All right. It was very pleasant the next day driving up. I was like, wow, also these snowplows do a great job, man. They like totally cleared the highway. It was like no slush, no nothing. So anyway, it's good to live in a modern world sometimes. I released grades for A3 and A4. A3, the median was 84, half above, half below. The average is quite a bit lower, but that's because there was a fair number of people that did not turn in A3, so 0 kind of weights it down. So 84 is not so bad. I mean, in this case, I think the main issues were some of the subtleties of logic sometimes to catch, what happens if the first smallest number is a negative value or something like that, and you have to have a little extra work to make that work. And of course, the times table thing caused all sorts of trouble with all the persnickety formatting requirements there. And don't get too disgruntled about losing a few points because of missing a space here or there. That was sort of the whole point, that it's really hard to lock down 10 different requirements and keep it all in your head. And if you got to lose some points to remind you that, that's okay by me. So don't feel too bad about that. A4 almost all did it correctly. A few didn't fix the bug in the count tokens method. Lost a few points there. If somehow the complexity of A4, I don't know. I'm worried there's some people that didn't do it just because of things weren't working out for you. If there's something I should know about, come back and talk to me about it, and we can look at what happened there. That was supposed to be just sort of a quick checkpoint for people. Okay. Next assignment's ready to go. So there's two parts to this assignment. It's not that much code to write, but again, the code's all important and it all has to work for the whole thing to work. This is sort of two separate projects. So in the first one, I want you to compare performance of binary search and sequential search. So we talked quite a bit about binary search. You have code for it. In fact, when you download A6, I have code that does binary search for you. And I have code that does sequential search for you. And what I want you to do is figure out how to say, for an array of a certain size, how fast can you find elements in there? And I have certain things I want you to do to test that. So read that carefully. Essentially, I want you to count how many times we look and say, is the value in the array equal to the key? That's the thing that we count as sort of the costly element of this project. So we're just going to count those up, and count them up for binary search and count them up for sequential search, and do some random stuff to kind of make sure we're not finding some special case where it gives us weird results. And you're going to write some code to kind of run these experiments in code. I think it's very important to be able to try to understand these search techniques, and sometimes the best way to do that is not always just from like looking at the code, but actually running it and running it in some sort of formal experiment kind of way. And so there's a little bit of code to write where you're sort of looping over and testing 100 times, you know, how long does it take to find 7? How long does it take to find 5? How long does it take to find 1,000,000 kind of things? And we're going to count them up and give back some results. And I want you to, you know, write down in a table, or if you want to, optionally a graph showing some of these results in a meaningful way. So part of your job there is to think about what kinds of things should I be testing? Like, is it worthwhile to test arrays of size 1, 2, and 3, or should I think bigger than that and think like different sizes of arrays will give me more information? All right, so there's some thought to be put into this. Now, the second one is to write a phrase completion program, which sounds kind of tricky, but this is again where data is king in some sense. It saves us from doing any real work. We just let the data handle any of the smarts, okay? So I have a file with 300,000 common 5-word phrases. So I don't know how these were collected. Really, they were like pulling in novels and newspaper articles and all sorts of stuff, and they just count up how many times, you know, I am a, I don't even know, good, 1, 2, 3, 4, okay. You know, that's a phrase, 5-letter phrase, right? And in all articles, they count up how many times that phrase appears, and we get rid of the ones that don't show up quite often enough. And anyway, so I started off with 1,000,000 of these, and I pared them down to 300,000, so there's a lot of phrases in there, right? And if I type, I want to search through these 300,000 phrases for all strings that start with that matching beginning. So I don't have to specify I am a good boy. I want to say the beginning of the phrase, and I basically return all the phrases that have that same start. So this is a search thing. I have to go through 300,000 phrases and decide how many start with that same key phrase. And with sequential search, that would take a while. Actually, still pretty fast with 300,000, but we'll pretend it's too slow. And with binary search, I can find it very quickly. So it's trying to point out that with binary search, I can very quickly search for things in huge data files, and it doesn't take much time. Now notice there's a twist here. I'm not trying to find a key, I'm a good boy, so I'm not trying to find an exact match. You have to modify binary search to say it's equals when just the beginning is okay. That's the trick in this assignment here. Okay, so you're going to just modify part of it to say that's equal, and so return that as a value. Now, this is not going to be a great phrase completer. A real phrase completer often looks at sort of which is the most important phrases used, so how often in all these books and dictionaries and newspaper articles I am a good boy shows up. And if this is a frequently used phrase, maybe I want to complete with I am a good boy versus I am a good cat or something like that. Maybe I am a good cat only shows up once and I am a good boy shows up 1,000 times. And so the completer should sort of look at these frequencies and rank them. We're going to ignore the ranking. So the phrases we get back are going to be kind of weird in that there's no sense of like relative importance for these phrases. Phrase completion shows up in a lot of different places. You've often seen it in, for example, Google, right? You start typing and it pops up a bunch of phrases. Phrase, come at me, bro, right? Oh, that's the one I want. I was really going for phrase completion here, so I was actually doing a good job. Sometimes it's a little scary seeing what's suggested, right? You've all seen the various memes of like, can you believe what shows up when you type, you know, something and, you know, some freaky thing. What makes this work on Google? Like, what makes it an effective tool for you?
They get a lot of data from people searching all the time.
Well, Google has an easy job, I'm saying, but like from your point of view, when you're typing, what makes this like a useful thing? It's fast, right? If you started typing phrase, com, and then you like sat there for a little while and finally it popped up the stuff, I could type completion faster than that, right? So it has to find this as fast as you type, basically. And so they're probably doing some sophisticated things, maybe not exactly binary search, but it might be an element of their thing, to make sure they can get that to you in like a 1/10 of a second, right? If it takes longer than that, it's not worth waiting for. And of course, search is not the only place people use this. I'm always relieved when I start typing UT and it knows Utah, you know, those kind of things, states and cities and all sorts of things. So phrase completion is a big part of a lot of modern programs. It's, keyboards on your phone suggest words and so on. They're all, there's different techniques again, but they're all sort of part of this family of ways of doing it. So hopefully, this will show you a little bit about what's going on behind the scenes with these phrase completers. And again, don't get too excited about the weird phrases you end up with. Maybe in the future you'll decide to revisit this task and add in frequencies and sort them and stuff like that. It wouldn't be that hard, I just don't want to do it. Or to make you do it, really. All right, so there's not really a section of just like a bunch of little tiny methods that do sort of practice things, right? There's sort of two tasks. One doing this testing, and the other one doing this phrase completer. But there's really only like two main methods in each one of those, so it's not that much code. But you have to sort of keep that goal in mind, right? That's the important thing. So I don't know. I got sort of a wild streak going here. Let's make some partners for this one if you feel like it. Okay. Now you don't have to have a partner. You can have a partner. There's some rules for having a partner. If you have a partner, you can't just say, hey, I'm going to do the experiment code and you can do the phrase completer code and we'll put it together and all be good, right? That's not allowed. And in fact, it'll probably show up during the test when you fail a test because you haven't figured out some of the things you should figure out from the assignment. So if you have a partner, you've got to figure out a time you can work together, typically on a shared screen, right? That's the best way to do this. So there's a cost to having a partner here, that you really need some chunks of time that you can actually get this done working together. If we get some code and, I don't know, we have some suspicions and we ask you to come talk to us and you can't explain what's going on in that code, we're just giving you a 0 for that, right? You just basically plagiarized off your partner in some sense there. So you got to know what's going on. You can't let stuff just slide by. Once things are going, you got to stick with the partner. So basically, I don't want a bunch of like, no, this isn't working out. I want a new partner. So once you start code, of course, it's you and your partner's code. You can't just branch off and get a new partner for that. In extreme cases, if things are really going badly, talk to me and you can just split off and submit your own individual assignments, but you can't reform into a new partnership. There's no time for that anyway, right? So don't think about this as just some sort of like test thing. Think of it more of a job. You're hired, you're together, you got to make it work for a week here or something like that, right?
Is this for like assignment 6?
Just for this assignment, yeah. We'll probably, if this works out okay, we'll return to it. Maybe not every assignment. There's some I want to make sure you can individually do some specific code. But there's others, I want you to bounce ideas off each other and see if that helps you learn a little bit better. So you might decide not to have a partner. That's perfectly fine. I do think there's some value, again, to seeing how other people think about this stuff, and maybe you'll get something out of it. Think of it as an alternative to TA help in some sense. If your partner is very forceful and has a bunch of weird ideas, maybe talk to us and see if we can redirect your efforts down the path we expect. There's always that, as soon as you do team stuff, it's just like brings all sorts of personality issues and drama into all this, and so, I'm kind of bracing myself a little bit, to be honest, saying you can work with partners, and then in 3 days there's going to be just like a million people screaming at me about their partner. So try to make it work. Be nice to each other, we'll see how it goes. Now, if you want a partner, there's a A6 partner finding discussion. And you said, if you don't have someone that you have in mind already. And so use that discussion board. You shouldn't just say, I need a partner. That's not enough to help people decide if you're a good partner. So try to say, here's a time I can meet. Here's all the days and times I can meet during this next week, kind of thing, right? Because again, the goal is that you can work together on this. Once you find some partner and you actually commit to each other, then take your name off that discussion board. So other people aren't like, you seem like a perfect partner, let's be partners forever, yay, kind of thing, right? So delete your comment and let other people move on. Now, I have to admit, I've used groups in Canvas before, more typically smaller classes with bigger groups, and I understand sort of how that works. I'm a little less sure how this is all going to work out. I haven't done this whole just sort of like make your own groups by yourselves and figure it all out. So in under people, which is a weird place to put it in my opinion, there is an A6 Partners tab, and I have just a bunch of numbered groups that can hold 2 people. And as far as I understand, you can add yourself to a group. So as soon as you find a partner, find an empty partner group and move the 2 names in there, and I think you're set. Now, as far as I understand as well, you only submit 1 thing per group. So you don't have to submit twice. And in fact, don't submit twice because that'll make grading hard. You know, one TA is going to be looking at your name, another TA is looking at the other name, and sort of wasted effort to grade it twice. I have not done groups before where some people are not groups, so I don't know if I should have made a whole bunch more groups where individuals could have gone in and submit under a group name, or whether you're going to be able have no trouble submitting as an individual. Let me know if there's some problems there. So I have, I have enough groups here for everyone to partner up. But I don't have enough groups if only 10 people partner up and everybody else wants to be an individual group. So again, if you're an individual without a partner, I think you don't need a group. But if that turns out to be wrong, I can try to fix this. Unfortunately, at one magic moment when I was doing this, Canvas said, you want to make your own set of groups? And I said, yes, make 140 of them. I think that option is now gone to add them. So if I have to make like another 100, I have to do it like 1 at a time or something horrible. So I hope we don't need to do that. Anyway, for the most part, just kind of keep me apprised if there are issues and let me know like what's going on with Canvas and all this stuff, and make sure make sure I'm not messing something up here, because again, it's a little bit uncharted waters here. There's sort of the support in Canvas for it. Groups are already this confusing thing in Canvas. In fact, Canvas doesn't want groups to be like lightweight 1 assignment groups. They want them to be like whole semester groups. Like you get your own discussion board, then like you can talk amongst each other. Anyway, there's whole infrastructure for these groups that seems crazy to me. So just let me know how it's going, okay? So, questions on that? Yeah.
Would you be like against if we're trying to work out a problem and like after we split, like we kind of like work on our own and come back and like share what we found and like discuss it? Does that make sense?
A little bit. That sounds basically okay, but you're kind of pushing the boundaries a little bit there, like.
Right.
Like it's good to think about it and debug it, but when you're writing the solution code, you should be together, right?
Okay.
That's kind of what that's the code should be produced together.
Right.
Yeah. Anything else? So, again, I would sort of urge you to give the old partner thing a try, even if you don't have someone you know in the class here, and see how it goes. Be a little careful about arranging times to meet and safety and all those kinds of things. Don't blame me when you sign up with your, serial killer partner. And anyway, I'm joking, but I worry about it a little bit, right? So if you have a weird vibe, just kind of bail out. Don't do it. Don't necessarily tell them you feel like the partner seems like a serial killer, but just say, I prefer to work on this alone now, or something like that, right? Anyway, just take care of yourself. Anything else on this assignment? So again, like in TA hours, if you have a partner, you should both be there to talk to the TA, right? Like, it's not really enough to have one person making progress on the assignment without help. Anything else?
When does this assignment due?
It's due next Wednesday
Wednesday?
at midnight, I think. Maybe I didn't write that down right, but yeah. So you have a week for this assignment, okay? We're all off cycle now. It's all. See, at some point we'll get back on. Okay. We're actually kind of moving up towards the end of one little phase of the class where we've been working on these static methods, and we're about to dive into actual object-oriented programming. I just want to wrap up 1 or 2 things here today that will help you on the assignment and a few other things that just slipped through. So, first of all, how can you tell what a method does? So let's say we have this public static in, compute things, takes and array of vowels. how do you tell what it does? Yeah.
You look at its return type and the parameters it takes in, and also, I guess, the name. They put a proper name to the method.
So hopefully the name is descriptive.
Yeah.
Compute things doesn't sound too descriptive, right? It's a little bit vague. And you're saying, look at, okay, we know it returns an int of some kind. It doesn't actually mean we don't know what that value is. We just know it's an int.
Right.
And we know it takes in some array of values. So it gives us some idea. Ints come in, an int comes out, and what else can we do to know how this works?
If they commented it well, you could look at the Java doc.
Comments are critical, right? Like they do explain, hopefully, more than just compute things. Compute things, sums up all the values in vals and returns the sum or something like that, right? So a good Java doc obviously goes a long way towards telling you what it does. Anything else? Tell you how something works? Sometimes, you've all been reading my Java doc comments and trying to figure out what I mean when to implement this stuff, right? So it's not that easy to understand the comments sometimes. Like, I have a certain idea what I think this thing does. You don't have the same idea, so it's a battle to understand that. So what else can we do to understand some of this code? Like what it does? Any other mechanisms? So let me just, okay, we've got, so we have the method name. We have Java docs. You've been doing assignments. What else have you looked at?
I mean, you could just read the code.
The code. That sometimes helps. Certainly, if you can actually figure out the code, you have a pretty good chance of understanding it, right? One of my colleagues, John Rivera here, likes to say code is king, right? Or code is truth. And now I forget what he says, but what does a method do? It does whatever the code says it does, right? And you can write all the Java docs you want, claiming various things about the code, but it's the code that defines what the method does. Anything else? There's one other thing I'm looking for here.
Run it with some examples.
Okay, yeah, run it. Test examples. And even more formally than just running it with test examples that you're writing. What else is test examples in it? JUnit tests. Yay, okay, JUnit tests. Like if those are provided, they kind of tell you, hey, this comes in, this comes out, right? They give you some sense of what's supposed to happen on that thing. So those are all some pretty good things. Comments, unit test, code. Oh, code is truth. Okay, that is king. And in the end, really, again, it's the code that defines what it does. And if it's some code that you can trust, then you're in pretty good shape. But if it's code written by your partner, then you better be a little more cautious about believing the Java doc. Now, there's other ways of describing a little bit about what happens. Java docs. So in our Java docs, we have our parameters that come in, the params tag. We have our at return, and some kind of rambling description of what's supposed to be going on there. And that's the part that I think is a little tricky, right? It's not precise enough often to tell you exactly what's going on. So there's another form of comments that people use that is there to tell you a little bit more formally about how to describe the behavior of a method. And sometimes this is sometimes called method contracts. So it's supposed to give you a more legal sense of these comments. In general, there's sort of three main parts that are described. There are what are called preconditions. And the preconditions are basically things that must be true for the method to work as described. So there's some assumptions being made in that method, and the preconditions are there to kind of lay bare the assumptions, to say, here are the things that I've thought about that I'm assuming are true for something to work. The post condition is basically what is true after the method executes, and that's closer to the return Java doc description. It says what's coming out at the end. And then we can also talk about invariants. And basically invariants are things that are true both before and after the method runs. And it's basically stuff that is not changing. So again, a lot of stuff doesn't change, and sometimes the tricky thing is figuring out what might be confusing to people and saying explicitly this doesn't change. So let's look at an example of these three things. For a precondition, when you say the precondition is this is what must be true, you're essentially saying that the code calling the method is responsible for making sure that it is true. That the method itself is not going to guarantee that happens. Now, on the other hand, a lot of times the method will check for those preconditions to be true, just make it a little more bulletproof, and report some errors if it's not met, return some error code, throw an exception of some kind. We're going to talk about how to throw exceptions. So when you do a precondition, you're saying, I'm assuming this is all true. To be a good coder, you can also add your own error checks to make sure that it really is true, and not just die and throw in, get a null exception or something like that. But it's not guaranteed that that's going to happen for other people, right? So it's your job when you call the method to make sure you've met the precondition cases. So what is a precondition for this method? So again, there's no code here, so we don't have any code as truth. But in this case, I think it's descriptive enough to let you know what's going on. It's called average. And to average, we take a sum and divide by n. So what do you think is going to be a precondition that must be true for this thing to work properly? Let me see if someone else wants to answer. Okay, what do you think?
You need to have an integer and a sum, an integer named sum and an integer named n.
Well, the code definitely has those parameters. In order for you to call it, you have to successfully, you do have to provide an int there. Yeah.
N can't be 0.
So n can't be 0. If you have n equals 0, then you divide by 0, and it's gonna die. So I don't have any. Perhaps I didn't have any special checks in there to make sure n's not 0, and so my precondition is going to be that n is not equal to 0. Is that what you're going to say, or?
Well, I was going to say it must be greater than 0.
Or yeah, it shouldn't be negative either. Yeah. So precondition n greater than 0. And again, you could say that in some sort of part of the params, or you could say it as part of some rambling description. But it's nice in some ways to have a more formal way of saying precondition, n is greater than 0. That must be true for this method to work as expected. Okay. What's the postcondition for this? Well, in this case, it's really trying to say what the method does, what it returns, in some sense. And there's nothing too exciting here to say that's different from what you would have said as part of the return Java doc, but it returns an int, first of all, so we know it's not going to return 2.5. So it returns the integer of dividing sum divided by n, right? Both of those are integers, and it's going to round down, or it's really going to truncate the decimal portion, and we should make that clear that we're returning an integer value here instead of a double. The invariant, this is too simple for an invariant, really. In this case, sum and end are unchanged. You're just adding them up, right? You're not actually changing the values. Even if you wanted to, methods can't change those values. I mean, you can change them inside the method, but when they come back, those changes are gone. So it's a little unnecessary to say this. I think more often you might use the invariant to say something about, let's say you pass an array into a method. You can change the contents of that array, right? You can change the values stored in each element. And so it might be nice to say, let's say this, instead of a sum here, we had an int array of values, and we wanted to add them up and get the average. We might say the values are unchanged, right? There's no need to change those values in order to add them up, and so we want to make it clear that that's an invariant during the processing. All right, so those are the three main things, and again, we'll see more examples that maybe help make that a little bit clearer. Let's write a little code. Make that bigger. All right, so let's make a method. And which one do I want to do here? Int sum, int a, int b. And return a plus b. All right, that's pretty easy. And here I can int summed value equals sum of 2 and 3. And let's print out sum value. Okay. Nope. Okay. So I can run this. And it loves to hop off the top there. So it's fine. Let's write a precondition for this. Now this is a little tricky. What's a precondition for this method? It's like so simple, right?
Must be integers, not doubles, or.
Well, and some of the compiler handles all that. In fact, you can do a little bit of, well, yeah, I mean, they have to be integers, right? We're passing in integers. So that's, okay, let's look at an example. Again, we use underscores instead of commas, right? So that's a big number, especially chosen. I'm going to add it up with 5. Is that right? No. That makes me sad. So add these two numbers, and we get back this weird negative number, right? What happened here? So this is where it starts to be nice to know a little bit about how computers are representing things underneath. And again, we're kind of been avoiding that in this class. We're going to just talk about Java. But an int is stored in 4 bytes of memory, which is 32 bits. Well, mostly, yeah. Bits are binary numbers, right? So again, we haven't talked about binary numbers, and that's sort of okay. But underneath in the computer memory, these numbers are all stored in zeros and ones. And the biggest number you can get is 32 ones. Well, yeah, bigger than that, right? It's 32 ones in binary, which is the same as, is that this number plus 1 maybe? I have to go back and see. There's some maximum integer value that can be represented by 32 ones. And in Java, we can find that with the integer class has a max int thing you can, max value. And that tells you the biggest positive number an integer can hold. And there's also a min value. And that tells me the smallest negative number that it can hold. What happens is if I have something that's like the biggest number it can hold, and you add 5 to it, 5 is 101. It goes through and kind of blows up this number, gets a bunch of 0, you get this other, it doesn't know that it can't hold it anymore, so it just sort of tries to add it, and it kind of calls, it's called overflow. It basically gets a nonsense answer off the other side, okay? And in fact, what happens is positive numbers wrap around to negative numbers eventually. So if you have a really big positive number and you add too much, it becomes a very negative number. So it wraps around like that. So that's all stuff that at some point you'll be learning about. And again, we're not going to go into it too much here, but there are subtleties with how computers represent things like numbers that can cause you trouble. And in this case, a subtlety was I tried to add quite a large number, hundreds, thousands, millions, billions, so something in the 2 billion size, and added 5 to it and got a wrong answer, right? Now this may seem like a pretty big number, but for example, let's say I'm trying to count up people on Earth. There's more than 2 billion people on Earth, and so it would start to run into trouble here. And so there are other forms of other ways of representing these bigger numbers that you have to use if you're going to be starting to deal with this kind of stuff. For the most part, we ignore it. We don't ever count up that big. But you can run into trouble at some point in your life. And in fact, there was some kind of error like this, an overflow error that caused the Ariane rocket to crash or something like that. I can't remember exactly the cause of it, but these kind of bugs are hard to catch and figure out. So a precondition for this might be that A plus B is less than or equal to integer max value, and that A plus B is greater than or equal to, let's say they're both negative numbers, integer min value, to avoid that kind of overflow, okay? And again, there's a lot of places where people ignore these kind of issues, and no one's going to blink twice if you just sort of say, return A plus B without having a bunch of if statements. If A plus, A is greater than this number and B is greater than this number or something like that, doing some careful checking on this, no one's going to really care. But in big systems, this is the kind of stuff that eventually causes things to go badly and, makes your self-driving car crash or something like that, right? So you do have to be careful with these kinds of issues. And again, just saying I add up A plus B, call it a day, that's true, but there are these overflow conditions that could happen, and this precondition kind of spells out exactly what might happen or what needs to be true for this to work as advertised. Okay? So even simple things have all sorts of room for error, I guess is what I'm trying to say. Kind of like those of you into lab, right? I was very pleased to see I had an error in my what method was that? The score word or something like that, right? Where I was assuming it couldn't have a 0 score to begin, kind of thing. And because shows that you have to be careful of this kind of stuff. And in fact, when I was working out the code for this assignment, I was like, oh, I better write a few JUnit tests just to let you all have some unit tests to help you out, kind of thing. And then it wouldn't pass my JUnit test, and I had a bug in my code that was assuming there was a certain number of things happening, and anyway, I was like, ooh, I'm glad I wrote this test and fixed it up. So, these are all helpful things, and even experienced programmers can get caught with simple mistakes, and it's good to have this infrastructure in place to kind of catch these sorts of issues, right?
So, question.
Yeah.
The precondition, when we write it like that, it'll actually do the test that we define?
It doesn't. This
Or
is just
that's
alerting
just words
people
that
that read the
we'll
code. It's just words, right? Now, the other thing is, Java Docs does not have a formal at precondition tag kind of thing. Maybe. And there are ways you can add your own tags into Eclipse, and some people do that. And there are commercial systems that make you write all sorts of very strictly formatted preconditions, postconditions, and it kind of writes the code for you to check all that stuff. So there are systems that sort of treat these coding by contract, it's called, where you have to actually, write this in a special markup language, and it does some stuff for you. But I would say it's not that widespread yet to have that enforced. It's more of a slightly different way of describing to a reader what the code is supposed to do.
So I know this is an example, but would having that as a precondition kind of be...
Like you got to add it up in advance?
It's like, hey, add this up and make sure
Yeah,
that
I know.
exceed...
It's a little bit tricky, right? How do you check if A plus B is bigger than this without adding the numbers up first, right? I don't actually have the answer for that easily, right? I think there are ways to check whether it's something overflowed and get an exception kind of thing out of it. Okay, so again, this is not really a way to enforce anything. It's just another way of describing what the method is supposed to do. And some people love this kind of stuff. I don't love it so much because it just seems like a bit of a pain, like more fancy words. When, just read the code instead, kind of thing, and be aware. If you're informed and know about things like adding overflow, then you'll be cautious of this and know what happens when it goes wrong. Not that you have to spell it out like each time, kind of thing. But don't take, that's just because I'm lazy. I don't like writing a bunch of stuff. So be a good programmer and write lots of stuff down that tells you how this is all supposed to work. Now, let's see. Let's talk about an issue that we've kind of avoided so far. This is a different from this precondition stuff. So Java is very big on safety. So I can do that, and Java has no trouble with it. It has a little trouble. The yellow line is saying I'm not using num, and so why did you put it here? But that's that's my problem, not Java's problem. Somewhat surprisingly, I can say, and if I print out val, it gets 2.0. So what's maybe a little surprising about this code here? What's going on with val? Yeah.
Combining two different types.
Where are the two types? I have a double here, and I initialized it with an integer, right? Now that's, like you said, there's two types. There's a double and an integer, and I'm assigning them to each other. And in some ways, Java should be nervous about that, because I should have typed here 2.0 or something like that, right? To make it clear, I'm assigning a double to a double. Here I'm assigning an int to a double. Java knows that, as strict as it is, it's given us a little leeway every once in a while. And the leeway here is that it says, okay, I can take that integer. Doubles can represent a range of numbers that are bigger than max value and min value. And so I will convert that for you and let that be okay. It kind of makes me uncomfortable, to be honest, to see this. It's sort of like, get a weird itch, like, that's an integer, So I think if you're doing this kind of stuff, you'd be better off making explicit what's going on and not counting on Java to do that for you, but it works. Now, if I try to do int num2 equals 2.0, it's going to complain to me. Cannot convert from a double to an int. And the problem here is that doubles can hold a much bigger range of values than int. And so even though 2 would fit in an int, it can't guarantee I'm going to not type in some super enormous number that won't fit in an integer. And it just, in general, it will not allow you to generically convert a double into an int. Okay, it's going to complain. Now, there are times I want this to happen. Maybe this is the result of some computation, not like a literal. And so I want to force this conversion to happen. And I can do that by doing what's called casting. So let's say cast the value. And I can say here, int. I think this is weird syntax because it just sort of floats out in front of the value here. It's not like wrapping it around it or anything like that. And this says, take this value and try to make it be an integer. And in this particular case, 2.0 does fit in an int, and so it can successfully print that out. And I'm still printing out val here instead of num2. I was like, okay, that's weird. Okay, so it prints out 2. All right, so you can force this kind of thing to happen. Now, this is sort of dumb code because, like, I'm initializing an integer with 2, and for some reason I'm insisting on writing this 2.0 and then making that an int, right? Like, why not just write 2 in this case, right? This is kind of like all going around in circles here. So just do that. But there are places where this kind of thing is useful. For example, if I want to get a double average equals 110 divided by 2, let's do 111. It's gonna let that work. Let's make this a little easier to do the math in our notes here. Okay, so I counted up 7 things into 2 groups, so the average of them, what's the average of this number? 3.5, right? And when I run it, I get 3. What happened here? The 2 numbers are integers, and so does integer division, right? Even though the answer eventually wants to go into a double. So it says an int 7 divided by an int 2 produces an integer, because we want to stay in the integer space here. And that's a 3. And then it takes this 3 and does the same kind of things I did up here. Says, okay, a 3 can fit into a double, so make it 3.0, right? But we've lost the 0.5 here. So, instead, I can cast that number to be a double, and an integer divided by a double forms a double, and so the 3.5 is preserved in this case. So this says, I know I don't want to divide these two integers together and stay an integer. Instead, let's make one of them a double, force this to be a mixed type math. Mixed type math goes to the most general case, which is double, and so you get 3.5 out of that. Yeah.
Are doubles kind of like more dominant than integers? You know what I mean?
They have a bigger range, and so they're dominant. In mixed case, that goes to the more general one. More general one holds more values. That's a double. So you can't go too far with that. So string val3 equals string 12. I'm not going to like that, right? You can only do it where it makes sense. Okay. And we'll hold off on my precious for each loop that keeps slipping by next time. So keep that in mind. This working with numbers, sometimes you've got to cast them and it's a little tricky, right? It's easy to make mistakes in your code based on that. Let me know how it goes for the partner stuff and all that kind of deal.